So let's take a look at what we have so far. I'll press play in the animation. And right now we have a very regular shape. We have almost a cylinder. And this is due to the fact that most of the particles are just being killed in the exact same place. And one thing I would like is some of the flames to be much higher than others. This would break much more the contour of the flames, and it will make it look much more natural. So let's work on that first, and then we will continue working with the rest of the forces. So what I would like to do next is generate some areas in the emitter that will have predefined live values. And we can do something similar that we did with the kill color. We can not only add a noise, so different areas have different values, we can also animate the noise, so throughout the animation we have different values in different places. So for now, let's turn off this delete. I will also turn off the set kill color, and I will make some room here. I will add a point VOP node, and I will call this age color, or add age color. I will also change the color of the node, and I will dive in. So same as the last time, I will add a turbulent noise. Make sure to connect the position of the particles to the position of the noise, and then connect the noise to the color. Let me increase the frequency. And I think for this example, I will reduce the roughness to 0.2. For this, I won't need much detail. I will also decrease the turbulence. And again, let's take a look at the ranges that we're getting from this turbulence. So go to the geometry spreadsheet, and here under the color values, you will notice that the highest values are more or less 0.46. The lowest values are around 0. So again, let's add a fit range. I will leave the source minimum at 0, but the source maximum I will bring down to 0.46. Now the destination minimum and destination maximum will be our minimum lifespan and our maximum lifespan for the particles. So we will need to promote these parameters to be able to change them and to be able to animate in case it's needed. So let's start by promoting the frequency of the noise, also the offset, and I will also promote the destination minimum and destination maximum. So let's go back. Let's also display our scene view. And probably the first thing I'm going to do is increase a little bit the noise patterns. So I will reduce the frequency. Also, another thing I want to do is animate the offset. So I will use the expression $F and probably multiply it by 2 or 3 times. And actually I was using T for time. Let's play just to see more or less what kind of colors we're getting. So I think this speed should be fine. If you want the pattern to change faster or slower, you can always multiply this with a higher value to generate faster movement, or multiply it by a lower value to make the changes much slower. So for now, let's stick with 2. I will probably also change the speed of the kill color. Let's multiply this by 2. So also our kill color is faster. And one thing I'm going to do differently this time is remove the color from this turbulence. I don't really want to see the color here. I rather keep the kill color for later. So I will disconnect this turbulent noise from the color attribute. And instead, I will add a bind node. This will let me export these values as a custom attribute. So let's connect this output to the input of the bind node. So just in case you're not seeing an input here, you can change the export to always. Now we have this input. And let's change the name of this parameter to life. So remember, life is an attribute that the particles will understand. So now if we take a look at the geometry spreadsheet, we should have here under points a life attribute that will be taking account by the particle simulations. So let's take a look at the result. Let's go back to my pop network and let's press play. And this is much better. Notice how some of the flames rise much higher, some are much lower, but we don't have the same pattern all the time. The pattern will be changing with the noise we just created. So this is much nicer. So before we move along, let's play with the values of the life attribute, and also let's play with the values of the forces that we are using inside the pop network. So first of all, let me increase the low values of the life attribute. And actually, let's change this node to set life, because we're not setting a color actually. And let's increase the minimum value to something like 0.4. And let's increase the maximum value to 1.2. And here it will be a matter of testing, basically to find a look that you're happy with. For now, I will go with this and try changing some of the forces that are in the top network. So first of all, I want to add a turbulent force that will break up the contours of the flames. For that, I'm going to lay down a pop force. Let's call this one turbulence. And what I'm going to do is increase the amplitude. Let's try with 1.5. And probably reduce the swirl size because I want somehow small flames. Let's try with 0.4. And another thing that I usually want to do with fire, flames, or things that move quite fast is reduce the pulse length. So this is the animation of the noise, or how fast the noise changes in time. Let's reduce this to 0.4. So here, the lower the number, or the lower the value you have, the faster the change will be. So this is starting to look interesting. Of course, we can play with these values, but before we do that, let me add a little bit of wind. And here I also want to show you something. We added a pop drag here that has an air resistance value. There are a few other nodes, for example, the pop wind, that also have this air resistance included. So I will connect a pop wind, and I will rather add the drag here. So let's call this set drag and wind. It's not a huge difference, just we'll have one node for both things. And I will add just a tiny bit of wind in the X direction, 0.1 maybe. And I will increase the air resistance to 3. So 3 is rather a high value, but this will keep these particles that are shifting away closer to the flames. So this is looking promising. I think we can now try to increase the number of particles. I will also increase the sub-steps of the simulation. Let's try with 2 sub-steps. I will also add more points in the scatter. So let's go to 5 times more. To have a denser distribution. And let's go to our source parameters and increase the constant birth rate. Let's go with 500,000 for now. So usually this kind of effects will require a lot of particles. Of course, it depends how close you are from the camera or how detailed you want your animation. Usually you will have numbers around the order of 1 million particles, 5 million particles, maybe even larger. I'll go with this for now and cache a few seconds. I may do a flipbook so we can play it in real time and then proceed with the color and alpha values.